So what is a bee tree?
That is what many young Americans have begun to ask themselves.
Many.
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 So
I guess many is
they
technically.
wake up in the morning and they ask, what is a bee tree? What could possibly be a bee tree? Well, we'll talk about what a bee tree is today.
Yeah, some people contemplate their existence and their purpose in life. Some people go, what's a bee tree?
What is a bee tree? It's a tree of bees. Nice.
I mean, not wrong, I guess.
So we're going to talk about bee trees. What type of tree have we talked about so far?
Binary.
Binary. And how many children do the nodes have up to?
Two.
2. So in a bee tree, instead of having 2, we're going to parameterize the number of children you have. That is the exact face you should make. So with the bee tree,
Just cry.
you can set n to be 101, and then every node can have up to 101 children.
That's horrible.
It is. I mean, do you want 101 children?
No.
I would be horrified.
Horrified?
I don't think
Are we
can
saying
have
directly
it.
related or not directly related?
We're not going to go into
I don't think
that.
it's physically possible to have that many.
Oh, there it is.
If
You
you're,
have multiple at once.
Look, you buy as many orphanages as possible.
That's when I put them up for adoption.
yeah, so you adopt them, right? So you could
Yeah,
always
yeah.
adopt them, right?
Yeah.
Yeah.
Oh, that's the
Except I think the South Carolina limit is actually 8, and by think I mean I know.
Have you tried adopting any?
I have the 4th one's adopted.
I did that.
Neat. Anyways, what are bee trees?
So back to bee trees. But let's start at least talk about why we want bee trees, because why would you want a tree? Well, actually, what would be the advantage of having a tree with more children than just 2?
Storing more data per, or directing to more data per node.
Sure, okay, well, you also store more data per node, but if you want to find something, what's the big O?
It's log-based, whatever amount of children.
Right. So log base 101 is faster than log base 2. So there's a couple advantages. But before we go into it, let's do a quick motivation. Let's see, index storage. So really bee trees were the first, and they're still actually used, data structure for using databases. So most, or at least most databases use some type of bee tree structure. The reason for this is it goes back to our spinning disks, which kind of are gone, but that's okay. You still have the same purpose. Where the idea is that reading something off the hard drive is slow, but reading, like, what was it, 4,096 bytes takes the same amount of time, roughly, to reading 1 byte. So there's no cost difference between, where there's, I'll say, minimal cost difference, or I should say negligible, that's the real word, cost difference between reading 1 byte and 496 bytes that are next to each other. Now, if the bytes are spread around the disk, then what I just said isn't true. But the point is, reading a chunk has about the same amount of time as reading just 1 byte. And reading from the hard drive is incredibly slow. Even with solid state drives, it is still very slow compared to your main memory and processing on the hard drive. We'll get way more in depth about that in architecture, but please just trust me, it is orders of magnitude slower. Usually the analogy is if you're hungry, you have food in the hand, that's just like on the processor. If you need to go to main memory, that's like driving to the store, buying the food, coming back and then eating it. Going to the hard drive would be like going to the store, buying seeds, planting them, watering them, waiting for them to grow, and then finally get your food once it's fully grown. That's the level of difference, if that makes any sense. So in other words, we want to avoid going to the hard drive as much as we possibly can. Crudely speaking, 1 disk access takes about the same time as 200,000 instructions. That's more like 2 million instructions now, but that number is only growing. If we used an AVL tree to store 2 million records, we end up with a very deep tree. Well, not very deep. Log base 2 of 20 million is 24, so it takes about 2 seconds to get to the end of that tree. We can't prove the log-in lower bound, but we can use more branches. So we can come up with a B tree, and I guess we'll go at the end and explain to you what this number turns into. when you use a bigger n. Let's talk about a B tree real quick. So a B tree is of order m is an m-way tree, i.e. a tree where each node may have up to m children. That follows these 5 rules. So these 5 rules must be maintained at each point in order for the B tree to still be a B tree. What is it? The number of keys of each non-leaf node is 1 less than the number of its children. Now, this may be a little confusing at first, but let's go ahead and make some numbers. Give me some numbers.
12. 19. 7.
And we need another number right here. 8. It's really hard to draw this on board. And then we're going to need another one, 6. Okay.
Okay.
Okay?
Great. I heard you don't like that.
Why, what's wrong with it?
That just.
It makes me sad.
That's very basic, but I know it's gonna get worse. So.
If by worse you mean more fun?
No.
Yes.
No.
Funner.
Incorrect.
More funner?
Please stop. Oh, you better.
More funner?
Stop.
So, in other words, there's 3 children, and the number of keys is 2. Why does that have to be the case? In other words, the number of children minus 1 is the number of keys. Well, you have to have 1 before the block, 1 in between each block, and then 1 at the end. If you add those all up, the number of children has to be 1 more than the number of keys, or you can say, what is it, the number of keys is 1 less than the number of children. Does that make sense? Has to have 3, 2. I mean, we could do it again, right? Because I know you can't wait to see another example. There we go. We good? You sure? All right. Just trying to make this easy, okay, Holland? What part of that's not easy? I know you just can't.
Not teach it to us.
I know you just can't wait to code this up. That's what you're waiting for. So all leaves are on the same level. Oh, so it's balanced.
Great.
All the leaves are on the same level, so you can't have something shooting off. All right. All non-leaf nodes except the root have at least m divided by 2 children. All right. And that's the C. Oh, you know about this operator? That's the ceiling operator. So I never set what m was equal to. I'll say m equals 5. 5 divided by 2, ceiling is 3, so we're good there. We'd have to add a lot more for this to make a little more sense, but we'll get to that in a moment. The root is either a leaf node or it has from 2 to m children. In other words, the root node is a special case. And what was it? A leaf node contains no more than n minus 1 keys. So once it has m keys, you have to do something. And that m should always be odd. That last point is really just to make all our lives easier. If you want to make your life miserable, you can try and make m even, and it'll make sense in a little while why that's the case, but for now, let's keep it odd. All right, hey, look, an example.
Oh, okay.
You okay, Holland?
No.
What's wrong with this one? It's great. You have 26. Everything to the left is lower than it, less than it. Everything to the right is greater. You're 12. You have between 6 and 12. Between the 6 and the 12, you have the 7 and 8. Right?
I don't get it. Why does that one have 4?
This one have 4?
No, no, 4. No.
Right here?
Yeah.
Because that's all that was needed. I mean, it's allowed. It's
Oh,
not.
I
Why
see.
does it have? This is an example of a B tree. So the question is not why does it have it. It should be, is that legal? And this is legal. So this can have 4. That's
So
fine.
it can have as many things inside of it, but like only.
Well, we have M, right?
Yeah.
Of order 5. So you can have at most 5 minus 1 nodes, aka 4. So the most nodes you can have are per Actually, the most elements you can have inside of a node, might be a better way of saying it, is 4.
Okay. I think I get it.
So how we do it? So let's construct. Suppose we want to start with an empty B tree and keys array in the order 1, 12, 8, 2. So here we go. We keep it in here. Notice that each node is really an array containing the nodes in sorted order. Why is this actually advantageous? Because this array can be read in one quick read from the hard drive. Remember, the B tree is usually used for a database, and you usually use a database either for stable storage or for the fact that your information doesn't fit in main memory. So B tree, you need to think in the idea that, okay, all this is stored on the disk. So reading the array from the disk, reading all 4 of those is the same cost as just reading one of them, is the best way to think of it. All right, to put the 5th element would violate condition 5. What's condition 5? A leaf node contains no more than m-1 keys. Ah, okay. So if we put 5 in there, it's not going to be allowed. What do we need to do?
Maybe another.
Let's go to the board and let's think about this. We have 1. That was the worst one I've ever drawn. 1, 2, 8, and 12. And we want to add 5. Where would 5 go?
Between 2 and 8.
Wait, are we adding 5?
I thought so, yeah.
That was our size.
Okay. So if we put a 5 here, it becomes this. But that violates condition 5, which is that your leaf nodes, which is what this is, can only have up to m-1 nodes. So what do we need to do? All right, where's that new node going to go?
Between 2 and 8. I guess that's
Sure. So is it going above or below?
below. I guess below 8 or above 2. I guess.
What's
Is
the
it
name?
oh, is it going to become a parent or a child? Let me put it that way.
Should it be a child?
Child.
A child. So you're saying down here?
Yeah. Is that wrong?
I'm trying to figure out. Okay, then where's the root?
Oh. What do you mean?
Well, currently root was right here, right?
It's still right there, isn't it?
And then you'd have this. Is this what you're thinking?
Yeah. Is that not?
That yeah, I'm trying to make sense of this. What makes more sense?
Oh. Okay.
Does that make more sense?
Yeah.
Yes. And then root, of course.
I mean, is it any more advantageous to do it that way? Like, as far as like coding wise?
Yes, because just moving it up here, you just need to make a note, put it up there, cut this in 2, and you're done. If you try and put the 5 below, you got to figure out who's going to be the root. I don't even know how you do that. But I was trying to see if you had some insight, and then we could, and maybe it was better than the regular B tree implementation. Then we could make the super B tree implementation, get a paper published. But that didn't happen.
I'll be honest, half those words kind of flew over my head for a second.
I love how we add, oh, we're adding 25. So let me go, we weren't adding 5, we were adding 25. So in reality, there we go, much better.
I like 5 better.
Me too. All right, then we want to add a 5, don't we? Oh, let's add 6, sure.
28.
So then 6 gets added to the side of 2. And then we get, what's the other one?
14.
12, 14, 25.
14 and 28.
Man, we have to erase things.
Yes.
Yeah.
Good. Good. As no, you don't understand. When I'm coding at work, nothing makes me happier than being able to delete code, because that means there's less code I have to try and fix later.
Yeah.
True.
Especially
I'll
when.
comment that entire section of code.
Ooh, no, don't do that. Just delete it. You have a repository, so you can just bring it back. Oh wait, we want to add 17. Where's 17 going to go?
That's when the repository is working right, but lately it's not doing that.
17. What do you mean?
So the 17, if we were following our rules, would go. No, I'm not.
You had to make another. Wait, what? You wouldn't. Would you make that the parent?
Hold on. All right. So what do we need to do? This is too big.
Yeah. So 17 would become the parent, but not like the.
You would be added to the parent.
Oh. And then the
Right?
root can't be more than 2, right?
The root can be more than 2.
It can be?
Yeah, the root is a special case.
Okay. Can't be more than 5 or 5?
I forgot if it can be 5. I'd have to go. I keep forgetting that rule. The root's a special weird. The root is weird. What was the rule? The root. All non-leaf nodes except the root must have that many children. The root's either a leaf or has from 2 to. So the root is allowed to have only 2. Sure. Oh, 2 children.
Yeah.
So it can't have 1 element. Okay, so the root's a special case. It can have just 1 element, but that's the only one that's allowed to. Okay, so hey, look, it turned into that. So this, I call this promoting the 17 to the parent node. So there it is. And let's keep going. There's that example. Okay. 1, 2, 6, so we add a 7. And then we need to add a, oh man, 16. This is gonna be so pretty. And then an 18.
48, 18.
Where'd the 18 go?
There was no 18.
There was never an 18?
It was
No,
never
it was
an
48.
Oh, it was 28. Y'all didn't stop me?
Eh.
25, 20,
Did
okay.
you not have a 28 before?
Yeah, I totally forgot to put it down.
Oh.
Came after this, 48, 52. What number are we going to add next? Let's find out. 63. All right. So let's add a 63.
You can't.
Yeah, we can. We had it right here, and then what's the problem?
You broke it.
I violates condition 5.
So you broke it.
It's not legal and you have to go to jail.
But in order to prevent yourself from going to jail, you need to promote someone or promote a number. What number were you promoting?
48.
All right, good. This is why you choose an odd number, because then it's easy to find the middle,
Okay.
right? Because if it was even, then you'd have to decide between 2 numbers, and that'd be sad. All right, you got this pattern? Okay. So then we promote the 48, and then we add a bunch more numbers. Adding 5 or 45 causes a split on this one. So you have to, if you add 45 to 25, 26, 28, 29, so right, the 45 would go on the end, right? Right here?
Mm-hmm.
And you'd have to promote 28, but if you promote the 28, now the root node is violating condition 5. So what do you have to do again?
Do the same thing with our, and make.
And promote the 17. So it turns into something like that. So in other words, this promotion scheme can trickle all the way up the B tree.
So it's kind of like the opposite of binary tree, where like adding to the top rather than the bottom? Or like.
No, we're still adding to the bottom. You still add to the bottom. But once you add it, you have to promote up if there's any problems. All right, so highlighting, inserting, attempt to insert into a leaf. If it will result in a leaf becoming too big, split the leaf, promoting the middle key. If this would result in the parent becoming 2 bits, split the parent in 2, promoting the middle key. This strategy might have to be repeated all the way to the top. If necessary, the root is split into 2 and the middle key is promoted to the new root, making the tree 1 level higher. How are we doing? Great. That's what I'm waiting for. No? Okay. All right. Are we going to do more of these? We'll do that in a second. We're going to do that in a moment. Actually, no. Let's do this now. So, who's ready to code this? Who's got this? You all ready? Emily? No one? No takers? All right. Well, turns out coding a B tree is actually very difficult. And I can do it, but I would not expect you to. So I'm not gonna, your lab is actually not to code this up.
Yay! God. I was about to say.
Yeah, our lab is to sketch it out and then post it on GitHub.
Yep.
Are you serious?
Yes.
Oh my God. I could do that.
Sketch it out step by painful step.
Just copy and paste. Just copy and paste.
Now,
Is that what this website's for?
yes, but I'm going to make y'all learn LaTeX.
What is LaTeX?
So LaTeX is what I've been basically using for all of my document development. It is think of it as an alternative to Word in Microsoft Office.
Okay.
Probably the best way to put it. When you start using it, it's going to be really annoying. But once you get used to it, you'll see when there are many situations where LaTeX is way better than Office. Of course, there's some times when Office is better, and that's simply when you just want to make a document real fast. Ooh, it's loading. So hopefully y'all logged in, made a user account. You can make a blank project. That's a bunch of interesting stuff.
Do we need to name the project anything in particular?
I'm sorry, y'all both spoke at the same time.
Yeah.
Go ahead, Blake.
Do we need to name the project anything in particular for submission?
No. Go ahead.
I would, but my laptop decided to spontaneous start updating.
Oh, okay, cool.
Oh, I
Well,
love that.
That's happening.
so that's a thing. Let me go down here. Now if you go, well, just keep following on. Hopefully
I like this.
this won't be too bad. Oops. Now, you can go ahead and install LaTeX on your local machine, but I'm going to warn you, it's going to take a really long time because LaTeX was started in the 70s, and it's one of these things where they didn't rewrite anything, they just kept adding to it.
Huh. How big is like the file?
How big is the file? So let's do this. So LaTeX produces PDFs.
Huh.
All right, let's see what happens. Recompile. Perfect. Okay, and I really wish I could make the screen bigger, but there's just issues with that. So,
Have you tried hitting F11?
no. You want me to try that?
Maybe. That's it might be a Windows thing, but
I don't know if that helped any.
Alt F4.
it made it slightly bigger across the board.
All right, well, this is all you get. So, ooh, does this just
Go back.
go back?
Go up to the left where it says recompile.
Yeah?
Go back down. There's a zoom.
Oh, look at that. It's pretty.
Every day.
Okay, so real quick, LaTeX. This is almost like, well, it's really kind of a markup language, except it's more powerful. So document class, that's just what paper you want to do. A4, I know none of y'all know what A4 paper is. That's okay, but you could put it in letter paper just like America. Then article, just to make it a simple one. English Babel, that's just so you know we're using English, UTF-8, so that's our input. Don't worry about the next one. Let's see, we don't care about that. Useful packages. Use package is like pound include inside of C++. So down, where we go? This is for math, this is for some graphics, and I don't use any of this right now, that's okay. But after your include, you have your begin document, and that's where you start typing up your document. And the one we're going to use for this class is called XY matrix. And this is so we can draw arrows from a cell on a matrix to another one. Notice how over here we have 0, 2 pointing to 13. And we're going to use this in order to at least start the exercise of creating our B trees. So let me show you how this is done. When you start doing this, it's going to be weird. That's okay. I'm going to copy this, go down here. And what's the first thing? Oh, we don't care about that. So we're going to insert 3, 7, 9, and 23. All right, so I'll type in insert 3, 7, 9, 23. Whack, whack means make a new line. Whack, whack. So backslash is called whack. Whack, it's whack, whack.
Okay.
And forward slash is just called slash. So slash is always forward slash, whack is backslash. The way I remember this is Windows likes the whack because it's wacky Windows. And everyone else uses slash or forward slash. But Windows is the only one where you have to do C: whack whack, as opposed to Linux where you just start with slash whatever slash, and Mac same thing. Okay, now the cells in here are delineated between the ampersand. So this is the first cell, we'll get rid of that 0. Next cell, get rid of that one. Here, we're going to not worry about the AR thing yet. And then what are our values? 3, 7, 9, 23. All right, 3. So 3 in that cell, 7 in that cell, 9 in that cell, and 23. And I'm going to give myself at least a little more space. Okay.
What's that thing after the XY matrix?
Ampersand C equals 0 PT. You can copy this from the template.txt file inside of Lab 21, which is what I highly recommend doing.
Yep, that part's already done. I'm just sort of figuring out what you've typed in already.
I'm just getting rid of these other numbers. And then I'm going to get rid of all these lines. And then let's hit recompile real quick. See what that looks like. Inserting 3, 7, 9. Ooh, let's do a comma after that. 23. And I totally didn't insert 23. There we go. All right, beautiful. So now we're going to insert, what's the next one? 45. 45. So then this is where things start to become nice, because now I just copy paste and I add 45. But what's the problem here?
No arrow. You need an arrow yet?
Well, I'm sorry, let me start here. M equals 5. Ooh.
Oh, so it's over 5.
Yeah, it's over 5. It's really sad I can't like drag this, you know. Yeah, it's over 5. So what do we need to do? This violates condition 5. So we
I don't know the word.
promote.
Remote. Okay. I'd say break it.
Break it?
Yeah.
What are we promoting?
9.
The 9. Alright, so we'll take this, take that line, go up here. Then we're just going to get rid of the 45. Keep that 9. Okay. And we're not quite there, because now we need to do the arrow thing. So AR equals arrow, and then you point in your parentheses the direction you want it to go. So we want it to go down and then to the left. So down, left. And then we want an arrow on this side, AR going down and then right? Or do we?
Want the and be there?
Yeah, let me put it over here. Wow, that's weird. And. So let's see what that looks like. See if we did that right. Oh, look at that. Of course, we really want that arrow to go to the 3, so let's add another L. There we go. How are we doing? Okay. I think you're starting to understand how this works, so I'm going to get rid of this. Get rid of that comment. Okay. Now, after that, we need to insert what? 1, 5, 14? So we're inserting the 1 that goes before the 3, right? And we need to update our arrow to go to that one. And then we're inserting the 5. That should go in here. So let's get rid of one of these on this side. Add it here, and then have our arrow go over one more to the left. And then 14, which is greater than 9, needs to go right here. And we need to push everything else to the right. Let's see if that looks okay. Okay. How are we doing so far? Kind of following how I'm doing this? I'm going to push this code, by the way. And actually, we can probably insert another one. What's the next one? 14, 25. Yeah, that one's still good because we can put the 25 right here. Another ampersand, and we're still good, aren't we? All right. And then we need to, now we need to add the 24. That goes right here. But if you look at it, are we good now?
No, we broke it.
Yeah, what do we need to do? This violates condition 5, so we promote, which one?
24.
24. What would I do?
No, you broke it.
I totally broke it.
You missed the X rating.
Yeah, I've missed that. There we go. So we need to promote the 24, so we'll get rid of that one. Promote it to after this, and this is where it gets a little weird. Because I think it's, was it \AR? What's it going to be? Down, 1, 2, 3. Down, 1, 2, 3. Let's see what that looks like. Oh, I guessed correctly. Okay. Yeah, I understand that the arrow is slightly off after that 9, but you see what's going on. I'm just trying to make this easy to put in. Otherwise, we'd have to be drawing it, and oh, that's going to be the drawing it by hand is annoying when you have to copy and paste it. This one's easier to copy and paste. Okay, so we promote. All right, great. Now what do? We insert. $13, $11, $8. All right, $13, $11, $8. Let's see what that does. Can we get this all in one line? All right, so we need to add the 13. So that's going to be greater than 9, less than 24. Or I should go over it. Greater than 9, less than 24, and before the 14. So we need to put the 13 here with an ampersand, and then we need this guy to go over one more because it shifts that arrow over. And there we go. Perfect. Now, what are we adding? We're adding an 11. Greater than 9, less than 24. So it's going to go here in the middle. So we're going to do it again. 11 ampersand. And of course, this arrow needs to go over again. Okay. Now we're adding the 8. That's, oh boy. That's going to go right here. And then that makes all the other arrows have to go over by 1. So right, right. Now we're going to have some long looking arrows. Yep. Okay. Are we okay?
No.
No, what happened?
Left side's too large.
This violates condition 5, so we promote the 5. Right. Alright, so let's go copy paste this real quick. So the 5 goes before the 9, right there. We get rid of the 5. This arrow is not going all the way over, so we need to delete 3 of the L's. 1, 2, 3. And this is, where is it going? Down. I'm going to just take a guess because I can't calculate it right now. Let's see how close I was. Oh, I nailed it!
So, yes,
Yeah! Are we good now? I think we are.
yeah.
Wait, hold on. All right, so we just inserted the 8. So what comes next? 19, 4, and 31. I think the 19th, yep, the 19th is going to break it. So insert 19. Whoops, that was the wrong button. So where does that go? Well, right after the 14, which again is going to update this arrow. Wow, that's making that guy really long. Recompile, and are we okay?
No.
No. What happened?
Let's see this. It violates the rules.
Condition 5. I'm writing the same thing over and over again.
Violates all the rules.
No, just condition 5. So we promote the
5, yeah, no, 14.
14. All right. Because if you have this on a final exam, this is how you need to write it. Hint, hint. All right, so this is going to get a little weird. So we got the 9. After the 9 points there, which is fine, then we need the 14 with another one that points, what is it going to go down? I think right 3 times, could be wrong. And the other arrow should, we need to get rid of one of the R's because we shifted it over. And let's see how close we are. Wow, that's annoying. Oh, we need one more after the 14. Almost guessed it correctly. Okay, how are we doing? Fantastic. Tired? Rather be coding it?
No.
Oh god.
Let's see, we promote the 4. Oh, actually, which one did we just insert? I'm sorry. We inserted the 19. So next comes 4, 31, 35. 4, 31, 35. And this is where we're going to have a lot of shifting around. Oh, we put the 4 there. All right, I'm going to do this. I'm going to get rid of one of these ampersands over here. Add the 4 there. And then I'm just going to have this go to the left one more. And I think that actually fixes that. Yeah, then it just points more that way. Perfect. And then what comes next? The 31. Where's the 31 go? It goes over here. So the 45 gets a 31 before it. We have 31 over here. Perfect. And then next comes the 35, which will go right after 35, right after the 31. So that should pop out over here. Are we still okay? Yeah, we're still okay. And then what was the last number? 56, of course.
Yeah, so it just has to come and ruin everything.
What are you talking about? What was it? Not photobombing, but crashing the party?
Yeah.
Yeah, that's it.
Had a good thing going.
This violates condition 5. Okay. So we promote the
35.
35. So let's see, 35, he's leaving. He's going up here, 35. We need to put another arrow down. We're gonna need a lot of arrows. I'm just taking a guess. Taking a guess. I was close. All right, Are we done?
By the way, we violated condition 5.
Yes, we have. This violates condition 5. So we promote the
14?
14. Okay.
The root is not exempt from condition 5.
No, it is not.
Just make a new route.
Yep. So let's get rid of this 35. Let's get rid of this 24 up here.
Meters aren't doing their job, you get new ones.
Yep. Yeah. Oh, there's the 14. So he's going to just go down and right on that side, and then down and left on that side. Get rid of the 9, and get rid of the 5, and then get rid of 14 in here. Yeah, let's see what that looks like. Ooh, I was close. We need to put the arrow on that side and have it go left one more. And then we need to update the arrow before the 24 to point to the 19. Let's see, down, 1, 2, 3. That's good enough. All right, how we doing?
Does 9 need to, like, does 7, 8, 11, and 13 have to be together?
No, they have to be separate because since the 5 and 9 are in a node, there has to be 3 pointers coming off of them, 3 children. So the first one's 1, 2, 3, 4, which is less than 5. The second one's 7 and 8, which is between 5 and 9. And the last one is 11 and 13, which is greater than 9 but less than 14.
Okay.
All right, how was that? Perfect. Let me go stop the recording.